Welcome back to System Software. So so today we're going to talk about version control, and this is essential for this class because all project submissions will be done via Git on the command line on USys. So we'll go over some basics of version control, and then I'll actually show you hands-on how to actually get things set up for this class. But first, let's look at homework 2. So homework 2 was due today. And it was just an exercise using these common command line tools to manipulate your file system, to move around your file system and manipulate your file system. So we looked at touch to create a file. Touch also updates the timestamp of the file. Remove, move, copy, make directory, remove directory. How come there's no rename? How do you rename? Yeah. You use move. Move also serves as a rename. Okay, so firstly, and so the exercise was take this current file tree that I had you download, that I created for you, and turn it into this file tree. So it's kind of like what's different here. And then use those file system manipulation commands to make the first file tree look like this file tree. So first of all, any questions about this process? Anybody have issues or questions or thoughts, concerns? Yeah.
So I did have a little bit of a question just with the file structure in the system.
Yeah.
Are we supposed to, when we're looking at it like this, I know it didn't matter when we made it, but for example, like min-file doesn't have a file extension at the end of it, whereas ACL does. Were we supposed to assume min-file would be a folder instead of a file?
No, it's a good question. So, new files maybe, well, that's talking about new files. But for this exercise, it didn't matter whether it was so if you had to create a file, it didn't matter if it was a file or directory. So extensions are as you'll find out when we talk about file systems, extensions have actually nothing to do with the contents of the file, at least nothing directly. The system doesn't enforce any sort of constraints on the actual contents of the file. This is really for user applications like File Explorer to pick what application to use to open it. And in the Unix world, there are certain types of files that don't have extensions. So programs, for instance. So when you compile with GCC, the convention is to put no extension for a program. Like when I type ls is a program. Oops, I got kicked out of USys. ls is actually a program, which can be found here. ls is an executable program, and you wouldn't know that by looking at it. And you can also just lie about the extension. So this has actually been used in attacks to give the wrong extension to something like program, call it a text file, to convince somebody to download it. So the extension is just the metadata. It's like the phone book, not the phone number. The data is like the phone number. We'll talk about that when we get to files. So the extension actually is irrelevant, especially for the Unix command line. The extension has not much meaning. Yeah.
Is there a way to undo? Because you said
for
messing up, just basically delete the whole file and restart it.
Yeah.
Is there any way to just if you mess up one thing, just go back?
Not with this shell. No, there is no undo. Although there's no undo. There's no undo. So that's why you got to be kind of careful with this. Yeah. So in windowing systems, they have a recycle bin, and you can actually undo certain actions. They actually will maintain undo. But here, I guess you could look at the history. Maybe somebody's written a tool like this to look at the history and have a more user-friendly system. But no, you have no undo. You got to do backups. Yeah.
What's the point of using terminal if it's so risky?
Well, it's fast. It's fast. And if you have there are other ways besides undo to have data integrity. So one way is to have backup systems. One way is to use version control, which we're going to look at today. So undo is not the only way to get that kind of integrity. But you basically get direct access to the file system through the operating system, through the kernel, and changes are basically permanent. You can undelete stuff. You can, as we'll talk about in file systems as well, delete does not actually remove the data. It just removes the name, just like the extension is not the data. It's just part of the name. But we'll see that when we get to file systems. But You be careful. There are actually, so I should say there are interactive versions or interactive flags for these tools. So, for instance, the -I flag, which is sometimes on by default via like an alias in Unix systems, it will prompt before you do any actual removals. So that's another protection that you could turn on if you wanted for this file system. But yeah, no, you're sort of kind of closer to the hardware here, closer to the machine, less protections for you. Yeah.
Do we ever go over like using command line for installing actual applications in this course?
No, we don't. That's a whole rat's nest of. Actually, I have some sort of little bit of open research on this problem. It's kind of a hard problem just to install stuff. Actually, just to install software is a hard problem because you have to have dependencies on libraries. But no, we're not going to go into that. Actually, I should say we will a little bit when we talk about build systems. So if you're talking about getting source code and building and installing it, we'll at least look at Make, which is a classic tool for managing those processes, including installation. So check out next time when we look at Make. We won't be doing any installation in this class, but we won't be doing that. Any other questions? Questions about the homework in particular? Yeah. Oh, true. Yeah, That's a good point. Yeah, I should probably put that here. I guess I was thinking these are the ones that actually change stuff. But yes, in order to know what's being changed, you would need change directory. I'll make a note to actually include that on here. But yeah, that's a good point. Yeah, question.
Is it alright if we use RM with the recursive flag to remove directories?
Yeah, you can do it. I just didn't show it because it's a little dangerous. Yeah, because it'll recursively not only delete files but also folders for an entire tree. Yeah.
Because I didn't know if we were supposed to use change directory, so I was able to do it with the commands just specifying which directory.
Yeah, absolutely you can. So I didn't specify that, but yes, that's a good point. So I would notice a lot of students like changing into a directory to modify stuff, but you don't have to do that at all because you can always specify, it doesn't take a file name, it takes a path. So if we're, let me go to a scratch directory here. Don't remember what, but yeah, there's no need to necessarily go into a directory, like change your working directory. You can do things like touch a file by giving the path to it. So now File Basics has this new file that was created. But yeah, I left that open so that people could try this in different ways, but that's a good point. Yeah.
I forgot my question.
Okay, let me know. Let me know if you remember. Other questions? Yeah.
Not about this, but I came in a little late. Will you have like a sign-in sheet for the attendance?
Oh yeah, I haven't taken attendance yet. I usually do it after I do the homework so that people have time to come in. So it'll be like, 10, 15 minutes into the class now. Well, or more than that. I had some announcements too, but they're on EdSTEM. Yeah, remember?
When we were submitting our assignments, I didn't really know exactly what to leave out of all the functions that I wrote out. Because like mine specifically was 50 lines. Because I
That's fine.
almost
Yeah.
didn't have to reduce it.
No, that's totally fine. It's totally fine. So I wasn't asking for like an optimal solution. That'd be a harder thing. So it's like the fewest number of commands. That would be like an interesting problem. But no, if you just went back and you did things again or you downloaded again, totally fine. Totally fine.
So I feel like at some point is there a limit of how many you want us to, or is it fine?
Not really, no. I mean, I guess whatever web courses limits you in like uploading to the answer, but no, not really. Not really. And remember, we're not checking for like 100% correctness. We're checking that you actually like attempted to do this, made a genuine attempt to do this. Yeah.
Was there a more efficient way of removing the hid subtree rather than just going through and manually deleting everything?
Well, so somebody pointed out the recursive flag on remove. Yeah. So you can recursively delete all the contents of a subtree with dash R. And I can't remember if I mentioned, I don't think I mentioned this last time, maybe I should put this in my notes, but there's also documentation built in to these Unix installations. So if you type man, short for manual, and then space the, actually we'll talk about this later, but if you put the name of the command after it, like rm for remove, you'll see documentation of its behavior and all of the flags, all of the options that you can alter the behavior of remove with. So for instance, you can have an interactive mode where it'll prompt you before each removal. There's a recursive mode where it'll basically delete an entire subtree. And other, you can just check this man page. So all of these commands, or most of these commands should have it, like copy. CD doesn't because it's actually built into the bash command processor. We'll look at that in a few weeks when we actually build our own kind of version of bash and see how that might work. Yeah.
Would the recursive flag work because it's a mix of files and directories you're deleting, or would it take care of that one?
No, it still works with a combination. Yeah, it just like builds looks at the tree, goes to the leaves, deletes those, deletes any directories because we can't remove a directory until it's empty. So it removes all the files, then deletes the directory, and so on up the tree. So it's basically a classic tree walking algorithm, like a depth first, or tree walking algorithm. All right, any other questions on the homework? Did everyone get it? Did everyone get the tree right? I hope, yeah. All right. Okay. So hopefully, let me know if you want me to do it. Do you want me to do any examples? Let me know. Do you want me to do any examples of showing that everybody's good? Yeah. No, I don't know it. I don't know the most efficient way. It'd be interesting to think of an algorithm for figuring out the most efficient way.
Can you show the answer again?
Oh, the answer?
Oh, did you show it already?
No, I never showed it.
Oh, sorry.
No.
Sorry.
No, we just go over it. Yeah. There is no one answer, so there's lots of ways to do it.
Okay.
The most efficient way, that's interesting. That's an interesting question. So you have to define that. So I guess the fewest number of commands, right? And maybe no options to them to make it easier. One way you could do it is just delete this whole tree and then recreate it, right? That's one way you could do it. Did anyone do that? There's nothing here that stops it, right? Stops you from doing it. You could have just done that. I was sort of hoping you would. Well, even if you did that, you'd still have to do make directory and touch at least. So you do part of it and remove. But I didn't show remove -r, so it would have been that would be a lot of steps, I think. That'd be more steps. But yeah, it's an interesting question. You could probably think of some algorithms for discovering, maybe some backtracking algorithm to discover, or dynamic programming like algorithm to discover the most optimal one. Hey, if you want to do a bonus project, let me know if you want to do that. That sounds like a fun one. You got to prove that it's the optimal one too, or at least convince me. Okay, so that's homework 2. Hopefully that was a good exercise. I just want everyone to kind of get your hands dirty, actually using the command line. And once these get into muscle memory, you can be extremely fast on the command line. That's one of the benefits of the command line. Who was using tab completion when you did this? Oh, not enough people. Yeah, so remember, to make this really fast, use tab completion. Hit the tab to see what files are available and to auto-complete those files for you. So that would have made things much, much faster if you didn't use that. Yeah.
Why do you hit tab multiple times and see the same result again?
I just kind of hyperactively hit tab over and over because I don't want to keep track in my head of 1 or 2 times tab. So I don't know whether it's going to autocomplete. So I just hit tab, hyperactively. Yeah. So I'll just type over and over until I get something. So just constantly hitting tab. Yeah. And just to see it work because it looks cool to me. Okay. All right. So that's homework 2. Yeah. So now let's do any other questions? Did I miss any questions? All right. Now let's do the attendance. Okay, So let me give you a crash course in version control, and then we'll go over our first programming exercise, the VC, or the virtual version control project, and I'll walk you through step by step exactly on the command line what you have to do to set up Git for this class. And also new this semester, there'll be a special repo that you also set up where you'll get your automated grading feedback, so you can see exactly how we scored your projects. Okay, so what is version control? Version control records changes to code, or really any file. You don't have to just use this for code. Git at least works with, well, it does work with text files and binary, but it has some built-in support for text to have to manage changes to each individual line of code. So why version control? So some of you have used it, so what's the point of using it? Why use version control at all? Yeah.
It lets us pull back in, so if we write code and then it breaks everything, we can then go back.
Okay, yeah, that's a really useful thing. I'm sure most people accidentally make mistakes and bugs. It's like an undo. You talked about undo for the file system. It is basically a file system, a snapshotting file system, and you can do undo by just rolling back to prior commits. Yeah.
If you want to change someone else's code, if you want to branch off someone else's code, it's useful for that as well.
Yeah, absolutely. So Git and a lot of these version control software support branching, where you can make your own copy of the software and do your own separate development. But I would argue that even if you're on the same branch, using version control when you're working with other people is really ideal. Who's ever actually copied a .c file to someone else? You weren't cheating, were you? You were just copying a file. No, but if you're trying to work collaboratively, copying an entire C file is kind of insane, right? Because now that file is entirely locked. If you make any changes, while they make changes, it's going to be a pain to try to merge it. And it's just kind of brittle because it's all the same name. You copy it back, you're going to overwrite your stuff. So version control gives you a way to have basically a snapshotting file system where you can record a snapshot of the history of that entire file system as you go into the future. And you can always roll back, like your colleague said, to look at prior versions of that code. So yeah, so if you have lots of developers working together, a really large, complicated code base, there's lots of useful things you can do here. You can rewind history. You can see exactly who changed what. So there's even a tool in Git called Git blame. So you can blame the person who caused the bug and have a history of that. And you can actually use it to track the causes of bugs. So if you encounter some problem in your software, even if that was introduced a year later, there are techniques like Git has a tool called bisect, and you can do a binary search for which commit actually introduced the bug. Pretty simple, right? You just check each version against your test case and see if it still breaks. And you can do a binary search to make that a little faster, and you can zero in on the exact commit that caused this change. Now, I won't go too much into this class, kind of best practices for using version control. But what makes this possible is not only just using version control, because you could just write 10,000 lines of code and then commit once. There are good practices for using version control, which you probably saw in your internship. You make small, well-defined changes to your code. You make messages that make clear what was changed. You include tests with that code probably. And you don't commit 10,000 lines of code, right? You commit small, well-defined changes, and that's what makes this kind of use, narrowing down on to specific causes of bugs, possible. But you'll have a chance to learn this in I think processes and senior design, where you'll actually have to do a larger project. In this class, it'll be mostly to get your feet wet if you haven't used it. Use it on the command line, and also make it so automated grading is really easy for us because we just pull your stuff from Git. It has a timestamp, so if you submit late, it's really obvious when you submit late. And you can also resubmit as much as possible. So in this class, submitting is you just push to Git. There's no web courses. There's no special system for submitting. You just use Git, and we can pull all your changes. And then, so that, if you need to resubmit, you can just gradually, incrementally make change to your code, which is the best way to make reliable code anyway. Okay, so let me explain version control with an analogy to a bank account. So let's say, you open up your checking account or whatever, and you see, well, I got $31 in my account. So that tells you how much you have right now, but it doesn't tell you how you got there. And version control is much like this. So when you copied your C file to your friend to work collaboratively, that's like you have only the latest snapshot of your code. But really in your bank account, you have a list of transactions. You can look and, so for instance, to get to this 31 account balance, I had some income, I had spent money on gas and food. And if you notice, you don't even need to know the total to figure out your current account balance, right? You can just add up all of the transactions to figure out what your current balance is. And I can even go back in time and say, what was my current balance at this date? I can roll back time in my transaction history because I have a list of all the changes. And so this is how version control works, conceptually at least. You don't ever need to have a final state of the program. You can just execute all of the sequence of changes to that source code to get to the current state today. See what I'm saying? So you start with an empty directory, and if one changes, well, I added a new Hello World file. Well, that change is recorded. If I expanded that to do more than Hello World, that change is recorded. And so you don't actually need to have a snapshot of the source code if you just have a list of all the changes to that source code. Does that kind of make sense? Believe me on that, kind of? So it's just like an account balance, where you don't actually need to know the balance of your account. You just need to know the sequence of changes to your account. And you add them all up, and voila, you've got the balance at any point in time in history. So that's basically how version control works. Maybe not under the hood, but conceptually it works this way, where you can always go back in history because you have a listing of all the changes, and you can add them all up to see what that code looked like at that point in time. Questions on that? Thoughts on that? Okay, so version control systems are software that helps do this for you, or at least helps do this for you somewhat automatically. And just like a bank transaction, when you save one of these snapshots or save one of these changes, you record a log message, which is not actually part of the code. It's part of the database recording the versions. And you record a log message that describes that change. And yeah, I think I linked in the notes here to some best practices for doing this. Google, for instance, has a really good guide on making what they call change logs. And so you can do this in your professional life or look at this on your own. I won't kind of teach you this or show you any or require any of this like sort of strict best practices. But that's what the log message is for. The log message is to provide metadata about that change. Okay, so let me show you how, at least conceptually, under the hood, version control systems work. Okay, who's used the diff tool before? Has anyone used diff? Oh, good number of people. What does diff do? Yeah, go ahead.
Shows you the changes from one file to the other file.
Yeah, it shows us the changes from one file to the other file, and only those changes. So if I've got this Hello World program, and I made some mistakes in my Hello World program. So if I wanted to have lowercase, I'm missing a comma here. I don't have a new line character. I've got a comment. And if I edit this file, or I need to fix this bug and make it look like this program, well, I could just edit the hello.c file, but then I'd lose the history of that file. So instead what I can do is I can keep both versions of this file, or starting with both versions of this file, so looking at the original one, which had the capitalized hello, and the new one, I can generate a listing of only the changes between the file. So, I'll show this version of it. So this is the kind of default output of diff. You can see that what's common between the files, like this include statement, the int main line, this last curly brace line, those aren't here at all inside of this change, inside of this diff. Instead, it's just showing the lines of code that have changed, that differ between the two. And so this left arrow means it's in the first argument, the file in the first argument, and this right arrow means it's in the file in the second argument. Does that make sense? So it's just a listing of only the lines that are different between the two files. Added and removed lines, yeah.
Does order matter at all? If you you have an identical line with two different functions, would that like register?
Yeah, order does matter. So the format that you'll see when using Git is this diff, I think, universal format. And so this has some extra information about the change, like the lines that it occurs on. It also includes some context for the change, which is the stuff that hasn't changed. And in this format, it puts a plus and a minus next to the lines that have changed. So the ordering here definitely matters. So it's saying that in order to get the new file, you remove these two lines and add this line. So there's no real notion in diff of a change. There's just added and removed lines. And so if you have a removed line and an added line at the same position in the file, you can think of that as a change. Okay, so that's diff. So we have this tool, this classic tool that allows us to see the changes between a file. So what's this have to do with version control? Well, version control, if we have the original file, if we keep this original file, and just like in our bank transaction, if we have the original amount, the original transaction, we don't actually need to ever store this file. Instead, all we need is this file and the diff. And I'm going to save this in a file called change.patch. And so if I have hello.c and I have change.patch, can I create the new hello file from it? Let me put it in the maybe more intuitive format. So if I have hello.c and I have change.patch, whoops. Yeah, thank you. If I have hello.c and this change, can I create the new hello file? Yes, I can, right? So the new hello file can be created by taking the original file, deleting these two lines, which this minus says to do here, and adding this line. And if you do that, you get the new file. So you don't actually ever need the new file. You can just keep the sequence of diffs. And if you have another change, you just keep that diff. And another change, you keep that diff. So if you have this sequence of diffs, you don't actually need to keep the entire files around. You can just keep the changed files. So let me just visualize this briefly. So if I have my hello.c file, and I take my change file, I will get my new hello C file. And what diff does, the diff tool will take any two files in, and it'll give you the changed file, the diff. It'll give you that patch. Questions on this? This make sense? So that's diff. And now there's another tool, a companion tool called patch, which reverses this process. It takes, so what patch does, this is really the patch tool. It takes hello and change, and it produces the new file. So if I've got my patch file and my original file, so it actually overwrites the file, so I'm going to copy hello into patched hello first. So I've got this file called patched hello, which is right now my current version of my file. So it still has capital H. Here's my change file. If I ask patch, I give patch the file I want to change, and I give it the change file, what am I going to get? Let's look at patched file now. Patched file is now the contents of new hello.c. You see that? Does that kind of make sense? So diff will produce any differences between two files. Patch will apply those differences to the old file to generate the new file. And so using these two tools, you can already kind of cobble together a primitive kind of version control system. You just use diff to record any changes you have, save those, And then you can always reconstruct the latest version of the file. Yeah.
What happens if you try to use patch with a change file that doesn't like actually match the?
It will reject it. So let's say I've already patched this again. So this is why this context information is useful. So it'll show you the actual line number and the contents of that line number. So if it can't be applied because it doesn't match the context information, then it's going to, actually here it even detected that it was an already patched version of that file. So let me just make some random file here and try to patch it. So if I try to patch it, it should reject it. So it says failed because the input file, the old file, didn't match this metadata, this line information and context information in the patch file. But yeah, that's a good question. So it won't even apply it. And you'll encounter this in Git as effectively a merge conflict, as it won't be able to apply other people's changes to your version of the code. So yeah, you see some nodding heads. Merge conflicts are horrendous to deal with, and it really comes from this, that change cannot be applied to your file. But if you do have a different original file and the changes are in a different place, like if two people are working on different parts of the file, patch will actually work. It can actually work, or at least Git will be able to work and merge these changes. Okay, so if you notice here, patch actually identified that I tried to reapply a patch to the already patched file, and it asked me if I wanted to reverse that patch. So the -r flag can take an already patched file. So here's my already patched file, and here's my patch. If I do patch -R and the two files, then it'll reverse the patch. It'll just reverse plus and minus, and voila, you've got the opposite of the patch. So it's like plus and minus, plus versus minus. It can reverse addition with subtraction. Yeah.
Two questions.
Yeah.
One, is there, how far back can you do these? Let's say you merge these two, or you merge two files, and you wanted to undo that, so you undid it. And then that file was merged with another file. Can you just keep doing that?
Yeah, for sure. Yeah, so this is what version control does. It actually, conceptually, it stores a diff for each change. And just like in our bank transactions, you can go back as far to the beginning of the sequence of transactions. So if you started at a 0 account balance and added 42, you can always go forwards and backwards in these changes to find the account balance at any point in time. And it's the same here. So these think of diffs as like a transaction that adds or subtracts code from your files. And you can always go forwards from older files and backwards from newer files to find a snapshot of the code at any point in time. Yeah. In the patch command? The first file. So patch takes, so I'll use the man page again here. Patch takes the original file and a patch file. A patch file is effectively the output of diff. That's the change file. But yes, this is what patch takes. So yeah, use the manual pages, and it'll help remind you if you forget how to use these commands, which I often do. But yeah, it even says here, it takes a patch file containing a difference listing produced by the diff program. Okay, questions on diff and patch? Kind of at least makes sense conceptually. Okay, so let's take a look at Git now. So the Git tool uses this principle, even if under the hood it may implement things a little differently. It uses this principle to record changes to your code. So Git has a pretty specific design that makes it stand out a little bit from other version control systems. For our purposes in this class, we've got 4 sections to our Git project, 4 pieces of our Git project. It's a little simplified. You can make more complicated arrangements with Git. But we have the working directory. This is where you're going to edit your code. So this is what you can actually edit and manipulate in your file system. Think of it as your checked out copy of the code. And unlike some other version control systems, it has staging area that you put changes into before you actually record a change to your database. And then we have the actual repository, the local repository. And this is where you save your changes to your code. And then we have a remote repository. So Git is distributed, which means anyone else can have copies of your repository as well. And it's truly decentralized, where there is within Git, there is no official copy of a repository. So GitHub is not a centralized Git site, because Git has no notion of a centralized Git version server. So it's more like kind of blockchain. If you ever heard of blockchain, it's like distributed or decentralized. Everyone can have their copy of the software. What makes it official is that outside of Git, someone gives the imprimatur of this is the official one. So my official code is on GitHub, or my official code is on my server. And this is where forks and branching come in, where if somebody doesn't agree with the trajectory of a project, they can just take their copy and keep changing it without merging changes back to other people's repositories. So anyway, we've got these 4 stages of a project. So here's the local part. We have the working directory, which is where you're actually going to edit your files. We have the staging area, where you're going to collect together changes that you want to commit. And then we have the actual repository, which is just stored in this .git folder, or .git directory on your local machine. So that's what your 3 pieces of your local repository. And then we have the remote repository, where that'll be on a different server in a different directory. So why might we have this design? Why bother having this intermediate step where we have to collect changes together before we actually write them to our database? Why don't we just commit? Why don't we just save these changes? I think you had a hand first, yeah.
Just so we can like keep track of our changes, test for any bugs, and before we push in, make sure everything is correct.
Okay. Yeah, I think that sounds reasonable, yeah.
Yeah, it allows us to double check when we're pushing, and also like maybe there's something we're working on that we don't want to push quite yet, so we can unstage it and like choose what we want to push.
Yeah, that's good. So it sounds like people have experience with Git. Yeah, this is exactly right. So you might have, you want to make sure you verify exactly what you want to change. This is one of the principles of using version control, the practices, where you don't just want to say commit everything I've ever changed, and then just say the word commit in your log message, I've changed something, because you're going to annoy your teammates if you're working with other people, and annoy yourself if you go back and try to find a bug. So the staging area allows you to be really, really specific about exactly which lines of code, not just the files, but which lines of code to add. And there is actually interactive systems on the command line for picking which files you want to add to the staging area and commit. But yeah, this is exactly right. And as you probably all have experienced, you may be making many changes to the code base at the same time, and you don't want to have your partially complete stuff pushed with your complete stuff. So say you were doing a bug fix and a feature addition. Well, you don't want to add those together because you want to have the bug fix cleanly separated and connected to the change, connected to the original commit that caused it, and do your feature commit separately. So yeah, great answers. Yeah, you had a question or a point?
Another would be that if you don't have that, there's no difference between just saving it normally and actually using version control. So why use version control? You could just completely take that out.
Well, it's still, so the commits are still diffs. They're still changing a diff of it. So the commit is still a diff. It's just the staging area is like, you can separate, so for instance, so basically you don't have to record everything in your working directory as a commit. You can select a subset of changes to commit beforehand. I mean, you can do that also. I mean, you can imagine the system doing that as well, separately, but it's still saving diffs,
Do modern systems not do that usually? Now, maybe it's just the IDE I use, but I know the IDE I use has that built in.
Are you using Git or using other version control?
Using ES code.
Yeah, so I mean, other systems have, there's sort of a debate about whether other systems have staging areas. I guess Git gives you kind of fine control over it. But yeah, IDEs can also kind of like emulate this, I suppose, yeah. But the actual Git tool on the command line allows you to do this. And we'll see when we, I need to get to the example. We'll see when we get to the example. You actually get feedback from the system about what's been staged, what's not been staged, what's been committed, and differences between your local copy and the distributed copy. All right, any questions on this? All right, so and we'll see actual examples of this. So the last point I want to show is that Git is distributed version control. So you might have lots of people working on the same code base, and the principle in Git is that everyone has a complete copy of the entire sequence of changes, and anyone can add changes and combine them together on a server or between other users, other developers of Git. So in this class, we're going to use a really, really simple architecture. We just have your local copy on Eustace or your machine, and then the remote copy is our submission server. And so for us, the submission server is where we do grading. So that has like the officialness to it. But in terms of Git, you can just freely push and pull changes between the two. So as long as you follow the instructions in this class, and you don't make, I mean, you can make multiple copies if you want of your code. But if you stick to the simple architecture we have here, you won't have any kind of issues with distribution like merge conflicts or different pieces of code. This basically means that you've made multiple changes to the same code, and then that can make things into a bit of a headache. This is what happened when I used to use GitHub for this class. People would like cut and paste or copy files to GitHub, and then they'd cause themselves merge conflicts. So if you stick to the architecture in this class where you just have one local copy and our server for submissions is the remote copy, then it'll be very easy. You won't have to worry about the distributed part of this or any branching or merging. Okay, so here's how you use and here's how you actually put files into the different states. So Emacs or an editor is how you modify the working tree. The command add will stage changes to the staging area. Commit will actually save that. That will actually save it to the repository as a change. And then push is how we synchronize those changes with the remote server. And as we'll see with the feedback server, pull is how you get changes from a remote server. But these four pieces are all you need to submit projects for this class. And this is a diagram of how the states will change. And I'll just show this when I get into the example. All right, questions on this so far? Yeah.
Does pull affect the same thing as push?
So
Repository, or?
So if you're local repository, if you push, that will move changes or copy changes to the remote server. Pull will copy changes from the remote server to your local server. So push is how you send those changes to another server, to another repository. So let's see some real examples of this. I want to make sure I get to the first exercise for class, and I'm just going to walk through hopefully exactly what you will see. It should be exactly what you're going to see when you go to do this project. Okay, so I am on this server. So first step, log into Eustace. Hopefully everyone is able to do that. And then there are configuration steps. Follow these. I've already configured my server, so for the sake of time, I'm gonna skip past these, but don't skip this step. You only need to do this once for the entire semester. It'll be stored in configuration files on your Git server. But you can just copy these and put your name in, put your email. So you can really just copy these. Whoops. You can really just copy these and set your email and set your name. These will just go into your logs with your changes. Yeah. Oh, sorry about that. Yeah, this is on the web. This is on the website. So it'll be in web courses. There'll be a link to it in web courses. It's also here on the website under the project assigned on this day. So it's in web courses. It's in web courses. Yeah.
Do you think we should get on Eustace or on a local machine?
Do this on Eustace. Do this on Eustace.
Okay.
So if you want to do this locally, talk to me. I can show you how to set up in what's called a proxy jump, where you can indirectly go to Eustace. But the submission server is, you need an SSH key. You need a signing key to be able to access it. And that signing key is automatically created in your Eustace account. You can download this and you can use it yourself, but this is more advanced kind of SSH stuff. So do this on Eustace for now. Yeah.
Is this going to be a class where we work in projects with Git, or are we just going to be working by ourselves with Git?
You'll be working by yourselves with Git, but you'll be submitting things.
Yeah, but I'm saying, like, because you're talking about merging people, like,
We're not going to do any of that in this class. We're not going to worry about. Yeah, there'll be no there's no collaboration. So even for my own personal projects, if I'm working alone, I still use Git because I want to have the history of changes because of the software engineering practices that it enables you to do easily. Okay, so configure Git, just copy these commands. I've also, in this instructions, I've also given you a command you can run to validate that you've done things correctly. So under each command, there's a section called validation, and there's also a section for errors. So if you encounter an error, it will walk you through, hopefully it'll cover all the cases. It'll walk you through what you did wrong and what you need to go back, what step you need to go back to. Okay, so also another important thing, set your editor to Emacs. By default, it's going to be Vim, and Vim is a little, if you've never used it before, the commands are a little esoteric. So change to Emacs, and all my instructions will be for Emacs. Yeah?
When we put in our email, do you want us to put in our UCF email?
Yeah, you could put your UCF email. We're going to know who you are by the access control onto the Git server, but it's just good practice to not be like John Doe for everyone. Okay, also another step, just so everyone has the same branch, set the default to master. This is the current default, but you'll get some messages about this if you don't set this. Okay, so let's see actually creating a repository. So what does this command do? Makes a directory. So we're just going to make a directory. -p just makes all the subdirectories along the way in case they haven't been made already. And then, oops, let me actually go through the validation. So to validate this is correct, you can run this command. It just will show the file if it's been created. And you can see here there's error checking here. So just step through here, look at all, if you encounter an error or something goes wrong, just look at the instructions and it'll link you back to the last step that the last step you need to run. Okay, what does this command do? Change directory. Oops, I didn't copy it. Okay, and you can validate it. Okay, so here's where we're actually going to start creating our Git repository. Git init will create a new Git repository. And all it really does is, well, not all it does, but what it does is it creates this .git folder. This is the actual local repository. This is the database of changes to your code. It's in this .git folder. Folders are hidden by default to ls, so you won't see it if you without extra flags. And you'll see that there's this really useful command that I use constantly when running Git status. Git status will tell you the status of your working directory, your staging area, your local repository, and your remote repository. It'll give you all the information you need about those 4 stages of submitting code via Git. And so you can see here, it says which branch we're on. The default is master. There's no commits yet, and there's nothing to commit. In other words, there's nothing staged. So this is what you should see when you type git status. And now we're going to create a new file. So this command, echo, all it does is it just writes out whatever text you give it. It writes it out to the console. We'll go over this more when we get into processes. But just copy this command. It'll create a new file called readme.md with the contents of EC project. That's all this command does. So we've made our first new file. And now if we type git status, Git will actually tell us, hey, there's a file in your working directory that I don't know about yet that has not been staged or committed to the local repository. And so that's why using git status is so useful. Make sure that you haven't missed anything that you haven't submitted yet. So there's git status. So there's some error checking here. Okay, so add is how we stage files to be committed. So you can see here it says readme is untracked, which means it hasn't been staged, it hasn't been committed. When I do git add and look at the status, it says changes to be committed. So that means it's in the staging area. And you can see there's nice color coding here to show you, something you might want to be aware of, something you might be missing, and something new that's happening in green. Okay, so we've staged the changes to our README file. And now we're going to commit. So I just have you make sure that the editor is Emacs first so that you don't get stuck in Vim, because you just, you have to do :Q to quit, and so you may not know that or remember that. And here's how you commit. So once the file is staged, you just type git commit and then the name of the file. So there are other ways to do commits and staging. I tried to give you one where you see the power of Git, but also it's easy to do. So we're going to do things by whole files. So once I do git commit, the editor will pop up immediately, because you should be putting a log message to describe what change you just made. So this is what can be like confusing about Git, because you get some like automated, you've lost the bash shell apparently. So here I recommend, the message doesn't really matter, but this is like a good message to hear. This is good practice. Have a nice present tense verb with the thing that you did. And then there's instructions here for how you actually save and quit Emacs. So Control S, Control X, Control S, Control X, Control C. If you did the tutorial, hopefully you would have seen that. And once I save the file and quit, Git will automatically record that commit for me. So it gives me some information about the commit. Each commit is assigned a unique ID, and it gives some information about the commit here. Now when I type git status, it tells me there's nothing to commit, there's nothing staged, and the working tree is clean. So my current working directory matches the local repository, matches the Git repository. Questions so far? Yeah.
Do the comments on the change log save anywhere?
No, yeah, those are just comments, just like on the bash shell. Those hash marks are comments. So if we, so let me maybe skip ahead a little bit, but git show will show you the most recent commit. And you can see this format may look a little familiar. This is the diff format. And you can see that our commit message doesn't have any of those hash comments. Those are all just comments for the commit file. Okay, yeah, and actually this is the next steps anyway. So git status is what we saw. Git show will list the metadata for the commit. So the commit ID, so you can see there's the author information here, the date, the actual commit log message that I wrote when in the editor, and then it'll show the actual diff file that's associated with that commit. So that's the change. This is our like bank transaction right here. Has all the metadata, who did it, when it was done, and what the actual additions and subtractions were. It's okay, so when you do this, if you've never done this before or on the command line, that's your first time doing it. Git log will show you the list of all the, Git log will just show you the metadata about the commit. Without the show will show you the actual change, log will just show you the metadata. So if we have lots and lots of changes, git log will show you all of them in the summary. Okay, so now here's the remote part. This part can get a little tricky if you make mistakes, but hopefully the validation and errors will cover you. So now what we need to do is we need to connect this local repository with the grading server. So this is the distributed part of Git. And so the way we do this is we tell Git what the remote server's address is. So this is the address for the remote server, Eustace 3. Don't log into Eustace 3, just use it for Git. This is the username and address. And this is the name of the repository. User here will just put my Eustace username. It'll just replace it. This just avoids you having to like edit the command line for your particular repo. So this will record in Git, here is the URL of my remote Git repository. That's what we're going to get. That's what we're going to grade from. We're actually going to pull all of your remote repositories based on your name. And that's where we're going to do our automated grading. We're going to pull from the remote repository. So you got to make sure that when you, I'm kind of getting ahead of myself here, but when you're working on your work, you got to make sure you're committing and pushing so that we see your changes. So I'll show you what that looks like when we don't have committed changes. But once you tell Git what the URL is, this command, which only needs to be run once with set upstream, this will connect the two. This will push all of the changes that you have locally onto the remote server and make sure that whenever you run git push again, it will always save to that remote server. Yeah.
Are we put stash in here as well?
Yeah, you can stash. So there's more advanced tools for Git. And so now when I type git status, I get some more information. So I get whether my branch is up to date with the submission server, so that's the shorthand name for the submission for your particular remote repository. I have some other sort of fancy commands here that show individual things. So this shows the mapping between the local repository and the remote repository. This shows the most recent commit that the remote server has, or at least where it is on the remote server. Okay, so this is what it's going to look like when you make changes to your repository. So I'm going to add a project description here. I'm just going to edit my README file. And so now you'll see, if I type git diff, this will run a diff between the working tree and the local repository. So this will show me what has changed. If I type git status, it'll tell me, hey, you've got some changes in README that you haven't committed yet. So if you're wondering why you got a 0 on your project or something broke, and you type git status, and you see that, I actually haven't committed all my changes. So the process for committing is the same. We stage the file, and you'll see now it says, instead of being not staged for commit, now it's changes to be committed, so it's staged. Then we commit the file. And see now status tells us that our working tree is clean. There's no changes, no differences between our working tree and the actual repository. But you can see here, it tells us that we're ahead of our remote repository, the submission repository. So in order to synchronize the local repository with the remote repository, what do? We just type git push. Because that previous command we did connected the two repositories already. So now git remembers, and all we have to do is say git push. And you'll see some information about this. And now when we type git status, it'll tell us we're up to date with the remote repository, and there's nothing in our working directory to change. So this flow of add, commit, push, this is like the standard flow for Git, and then using status, as obsessively as hitting tab, will keep you aware of the state of all these phases of Git. You don't have to keep this in your head. You can type git status. Here we can also see if we type git log, we'll see both of the changes here, and it'll even tell us where the remote repository is. So this tells us that the remote repository is at the same place as our local repository. Okay, so that'll help you. Yeah, go ahead.
Is there any reason not to use git add /all?
Really bad practice, because for the same reason that they have the staging area. It's there so that you don't accidentally commit things you don't mean to commit. So that's why I teach it to you this way. So one very, very last important thing, this feedback repository, and if you give me bear with me 1 minute, this feedback repository is where you're going to get your automated grading reports. So just follow the directions on here. This is going to create a new directory on Eustace called feedback. It'll start out as an empty repo, but you'll see that if I go to actually grade, I'm going to grade myself here. Oops. Let me just grade myself. Hopefully it works. So this is automatically going to pull your changes from the submission repo. If it's just on Eustace and not on submission repo, we won't be able to see your changes. Make sure you do git status to see it's synced up, git push to sync your changes. And then once the grading is done, we're automatically going to push a report showing you exactly what you got right and wrong. Once you've submitted your project and all your changes are up to date with the local repository, and your local repository is up to date with submission repository, you can go to your feedback repository, which we created, and use git pull to pull any files that we have submitted there, pushed there. These are your grading reports. So if you look at the VC directory, which is the name of this current project, you can print that report out. You can look at that report, for instance, using cat, and see the breakdown in score for your project.